All right, so we're going to be going on now to solving multi-step equations, and multi-step can go anywhere from 3 to 4 to 5 to 6 steps, just depending on what's involved. And so your book gives some nice steps right here, and I kind of like it a lot. So this just comes from page 50. So if you want to take a look at that, I've also just done a cut and paste right here. So here are the steps, and you're going to skip the steps that don't apply to the problem. So for example, in this problem right here, it says clear fractions or decimals. Well, there are no fractions and there are no decimals, so we don't have to do that step right there. Okay, because this one doesn't have it. It's just that these are the steps that we're always going to use now for multi-step equations. So we're going to skip that one. Simplify each side. So we're all going to do that one right now. And so check this out. It says use the distributive property to clear parentheses, which we don't have any parentheses, but then it says combine like terms as needed. Okay, and so again, the goal of step 2 is to simplify each side. So let's look at each side separately, and let's combine like terms. Are there any terms that we can combine on the left side over here? And I think the answer is yes, right? 4x plus 8x. I mean, doesn't that give us a 12x, right? It sure does, right? And so again, think of our dotted line right here. I'm just going to draw my equal sign directly below that. And that's the whole purpose why I do the dotted line, is just that the equal sign should always line up. Always, always, always line up. It should never, sometimes it kind of makes the problem look messy, but it's just to kind of get you used to where the equal signs are always in a straight column there. And then if you look on this side, look at you can combine negative 9 and negative 1. So negative 9 minus 1 is a negative 10, and then we bring down the positive 17x. Okay, so that's really the first step in this problem, is we simplified each side by combining like terms as needed. Okay? Now it says isolate the variable term on one side. So it says using the addition property and basically using the opposite operations, what we've been learning about. You want to put the variables on one side of the equation and the numbers on the other. This is extremely important now. We want to put the variables on one side of the equation and the numbers on the other. So take a look at what I have here. 12x. 12x is going to be represented as a variable. I'm just going to put a v above it. Negative 10 is going to be represented as a number, and 17x is going to be a variable. So can you see that all of the numbers are already on the right side of the equation? Variable, number, number. I'm sorry, variable, number, variable. There's one number over here, and it's the only one, and it's on the right side. So I'm going to keep the number there, which means I need to take this variable and plop it over here on the left, on 12x. Okay, because this step says variables on one side of the equation and the numbers on the other. So I need to put this 17x over here. And the opposite of adding 17x is subtracting 17x. You see? 12x minus 17x, and it's going to give us a negative 5x. Again, the equal sign should always be on this line. Drop down the negative 10 and 17x, those just cross out. So, and then now we're going to use the multiplication property, which basically means we're going to multiply or divide both sides to get our coefficient of 1 right here. So this is negative 5 times x, so the opposite of multiplying by negative 5 is dividing. So let's divide both sides by negative 5. So I get x equals 2. Well, bam. And that's how we get that answer right there.